My name is Adria Bondanza, and I'm a science teacher at Sun Valley High School in the Pendelco School District. And this morning, I'll be talking to you about indoor contaminants and long-term health effects. So what we were trying to find out in this study was if synthetic chemicals found on dust particles lead to long-term health issues. So when you think about it, most of us spend 90% of our time indoors. Having said that, we need to be concerned about indoor air quality. There's increased awareness about outdoor air quality, and we've made improvements to that, but indoor air quality has not been studied nearly as much. We do know that particulate matter, which is a mixture of solid particles and liquid droplets, can enter the respiratory system when it's small enough. And typically, we're concerned about particulate matter when it's 2.5 micrometers or smaller. Obviously, the smaller the particles, the further it can travel into your respiratory system. One type of particulate matter that's extensively been studied are protein allergens. We know that exposure can lead to allergy and asthma. So our hypothesis was that since synthetic chemicals like insecticides, pesticides, plasticizers, and flame retardants are on the same scale as protein allergens, they can cause serious diseases over time when they're inhaled and they accumulate in a person's body tissue. It's really important to understand the potential risk of this sooner rather than later. If you think about black lung disease, for example, no one realized long-term health effects of working in coal mines until they saw many miners develop similar symptoms. And after performing autopsies on miners, they realized the effects of coal dust on the respiratory. So the issue with synthetic chemicals is when they attach to dust, they become aerosolized and they can enter your respiratory system. And there's evidence that these are endocrine disruptors, meaning that they prevent the normal function of the reproductive system. Many chronic health issues like premature births, low birth weight, low sperm count, certain forms of leukemia, infant microcephaly, and others are statistically associated with particulate matter containing synthetic chemicals that I mentioned. So while these chemicals are designed to be harmless, we don't know long-term effects of exposure to them, and we're concerned about bioaccumulation. There's several parts to the study that we did. First, we wanted to examine how particles travel through the respiratory system. We used the ICRP equation. This stands for the International Commission on Radiological Protection. This was actually developed during the Cold War to make predictions about the effects of a possible nuclear fallout. The way they did this was autopsies were conducted, and the equations actually derived based on which size particles accumulate in different parts of the respiratory system. Second, we want to see what literature was already available. A lot of the literature is from international studies, not as much in the United States. We're looking for correlations between exposure to synthetic chemicals and long-term health effects that support our hypothesis. And third, we collected dust particle samples and sent them for analysis, looking at both particle size and the presence of those various contaminants that I mentioned. And then final piece is we're going to look at mechanisms that cause dust to become aerosolized using a school building, specifically my school building, as our laboratory. So looking at the samples that we sent out, there's a lot of things that we figured out from our samples. First, we found that many significant indoor contaminants are carried on micron-sized dust particles. This includes those synthetic chemicals I mentioned, as well as protein allergens. Second, we found that particle size distribution of particulate matter carrying contaminants is critical for risk assessment. Basically, this means that the smallest particles are of the greatest concern. Third, we found that aerosolization varies significantly with particle type and size, and resuspension can be quantified. When you look at house dust, the majority of house dust is made up of small particles when you look at it by number. And while small particles may not resuspend as easily as larger particles, there's just significantly more of them. Finally, the quantification of risk of inhalation requires advances in particle size distribution determination, size segregation of bulk samples, and analytical sensitivity for detection of contaminants. So in other words, we need to be able to separate particles of different sizes and then determine if certain size particles carry certain synthetic chemicals. This would also help to determine where those chemical contaminants will travel in your respiratory system. The ultimate goal with this is to be able to develop cleaners to try to take those certain size particles out of the air, especially nowadays with the pandemic. Indoor air quality is really becoming a big concern for everybody, as it should be. I'd like to thank CSATS and the RET program and NSF for their funding and support. I'd like to also thank Dr. James Fryhot for his invaluable expertise and endless help with this project. Thank you.